Good day, everyone. I am Jonathan Taisambayan. Today we're going to explore the behavior of gases using the Phet simulation titled Gas Properties. This will help us understand key concepts like how gas particles behave, how temperature affects gas, and how pressure and volume are related.
Now, we have already opened the gas properties simulation. In this simulation, we can adjust several factors including the number of gas, particles, the temperature, and the volume of the container. Now notice the container on the left side. We'll begin with the default settings. But feel free to follow along. You can see small particles moving around inside the container. These particles represent gas molecules. Now let's take a close look at the gas particles inside the container. We can observe that they are moving rapidly, bouncing off the walls of the container. This is what gas particles do in real life. They are constantly moving in all directions. Well, on the right side, you'll see the temperature indicators, that is in Kelvin, as well as the pressure gauge, which shows the pressure inside the container. As we interact with the gas, these values will change. Now let's start by changing the temperature of the gas. In the bottom left, you will find a slider that adjusts the temperature. Try increasing the temperature and watch what happens to the gas particles. As we increase the temperature, the gas particles begin to move faster. This is because higher temperatures provide more energy to the particles, making them move quicker. So, can anyone guess what happened to the pressure as we increase the temperature? That's right. As the particles move faster, they hit the walls of the container more frequently and with more force. This increases the pressure inside the container. Now let's explore how changing the volume affects the gas in the container. In the top left of the container, you can adjust the size of the container. Now try reducing the volume and observe what happens. When we decrease the volume, the gas particles have less space to move around. So, they collide with the walls more often, increasing the pressure. Try expanding the container as well. And notice the pressure decreases as the volume increases. Now that we've seen how pressure and volume change when temperature, let's discuss the relationship between these three factors. This relationship is described using the law of the ideal gas law. Using this law, we can understand that pressure, volume are inversely related at constant temperature. This means that when the volume decreases, the pressure increases. Likewise, pressure and temperature are directly related. When the temperature increases, pressure also increases. While if the volume is constant. So that describes the ideal gas law, describing the relationship between volume, pressure, and temperature of the gas particles. To conclude this discussion, what did we learn today is that we saw that gas particles move faster and increases pressure, while changing the volume affects the frequency of collisions with the walls of the container. Keep these concepts in mind as they're essential to understanding the behavior of gases in many scientific and everyday contexts. I hope you've learned something in this discussion. Goodbye!